I'm back due to popular demand and some requests for some clarifications on last night's panel. And for the guys who missed it, there's a recap or a rehearse. We'll keep it concise and short. By the way, on the previous one, I've got 4 kids. I don't know if it qualifies for a big number. It's got 4. As for the learning fast, I'm not sure. So ASOCS is really about digital transformation, and I'm sure you heard that term lots. And what I'm going to try to achieve is just to give you some basics, instincts, and insights about what it is, and hopefully making it interesting. But before we go further, just a little bit of tribute to George. And we all know him for writing books, but George is also a very savvy investor and observer of technology. And we've been very, very lucky to have him on our advisory board since 2012, where he gave me, literally sent me a check. I'm not going to tell you the number, but he sent me the check when I went to visit him in Berkshire. It paid for the coffee and the fuel for sure. So thank you very much, George, for participating. And another person who's right here is Jerry Frigon. Jerry, are you here? Could you just raise your hand? Jerry has been supporting us for a very long time, so thank you very much. The other corporates, we don't need to thank them. They got a lot of money, so I think they're spreading it around. But really about why am I insisting on hammering this industrial 5G topic on you, where we have so many issues about persons and birth rates, is one of the real answers is that, as you saw in many, many countries, there aren't going to be any more people to do any more jobs. And the staggering effect is even in China. There's a shortage of workers in factories. So I'm not even talking about South Korea, Japan, or Germany, who kind of gave up on that. But even in China, there's a shortage, and we need to still produce stuff. So this kind of innovation and efficiencies need to come through knowledge, through connectivity, through information, the information age. And this is why it's such an important area to work, to innovate, and to invest. So very high level, we're not going to talk about our technology too much, but just say we're part of 2 major trends. One is that we managed to turn physical communication infrastructure, those ugly boxes that you see sometimes in cranes near your big cell towers, into software that runs in the cloud. Trust me, it works. That's all I have to say for now. And it's all open standards where companies can collaborate and work together in order to create new systems. This trend is called Open RAN, or Open Radio Access Networks. And our software sits at the heart of these new systems. Originally, targeting to change the AT&Ts of the world. After we kind of gave up on those, we went ahead and we went to the private sector, where enterprises care about efficiencies and quality and things that matter, and less about other stuff that may not matter. The second part, we talked a little bit about the panel last night. People asked me some questions just intuitively. Positioning has been done for the last 60 or 70 years, starting with trying to figure out stuff using radio waves, and then we've got satellites in the sky, and we all love our GPSs. But in this, in building for sure, GPS doesn't work, but the GPS issue has been under attack in so many ways. What we have managed to figure out a way how, without really knowing where items are, have a very good guess of where they are using AI. And the basic intuition is that if we measure a sample, a data set of a few real points in which real devices are at, we can kind of figure out later using deep neural networks where the other ones would be. And that's a very simple concept in AI. It's just a different type of AI from the ones that we've been talking a lot during this conference. This is called physical AI. It's using sensors to create the data sets, while in ChatGPT, we're using the words, we're using something which is finite. In this case, it always changes. And that's a bigger challenge because we're trying to kind of model reality. So our role as a small company is, of course, very big, or at least we would like to think so, because when you look at the world of industry, it's been there for a while, and although there is innovation there, it was always very shy of treating this new world of communications and IT from the cloud. And there's a gap, and there's a very strong need to connect these cloud and software services, and today the omniverse, which is becoming very, very important in the physical AI, to the end customer. And the end customer could be a man, could be a machine, and this is our role. So we're kind of the glue, the thing that binds the world of cloud to the physical world, and that's a big challenge. So just diving very, very quickly, people came and asked me, they said, okay, we saw these robots and we understand that they're moving autonomously, so what's this communication thing? The reality is that even autonomous robots need to be controlled and need to share their information. Hence, they need to move the information they create, whether it's through cameras or radars or whatever, upstream. And then somebody in a higher hierarchy needs to process it and brings it back. So that's sort of like the closed loop model that makes hopefully a lot of sense. But if you think from an AI perspective, it doesn't make sense to put these massive power hogs from NVIDIA on every single device that you're going to have. And eventually, you're going to need to find a way to make these robots autonomous on one side, but brainless on the other side. And the only way to do it is have this ultra-reliable connectivity, location information, and metadata moving back and forth. And the innovation that we bring to the table is that while today, in the old Intel facilities, that information would have been uploaded every 15 minutes, we're doing it 100 times every second. That means we sync this robot more than 500,000 times a day. That's a very big number. And once you get to that kind of scale of number, you can actually treat the robot as part of a higher hierarchy, and robots could collaborate. Robots can collaborate with persons, and it makes it much more, it levels the playing field of these physical AI to the world of the edge cloud or the fog cloud or whatever you want to call it. But there might be even a bigger goal, a bigger task that I'm going to share with you very, very quickly today, and that is the digital twins. So a digital twin, how many of you heard this term before? Okay, that's very good. Most of us believe the digital twins is a sort of like of a simulation of what's happening in the real world, and that's a very fair assessment. The issue with digital twins, where companies spend sometimes tens of millions of dollars to create, is that it's very hard to maintain them. Taking a step back, what is this simulation for? Well, it's not just for games and for CEOs to show their capabilities. It's really about being able to simulate stuff before it happens. So in this conference room, I could simulate what would be the effect by changing the tables and chairs, and how would people see the screen as an example before I actually do it. But what if I could also simulate how do you guys feel in terms of air quality, of temperature, of all these things? And in order to really simulate that feeling, I got to really know what is the impact of this cloth on the table, of these rugs, how much dust is in the air, what is the effect of the lights. That is a physical digital twin. If we can get to the level that we simulate the reality to perfection, now we have a powerful tool to figure out and to do so many things before we actually do them, and in conjunction to reality. So at the end of the day, today, there's a physical world. Yeah, it's got robots, it's got people, it's got dust, it's got noise, it's got smell. And there's a digital twin which is very, very synthetic, It's very geeky sometimes. So there's a challenge. If we could synchronize the physical world and the digital world constantly, we could bring a lot of efficiency and value, quality of life, dollars to the bank, whatever you want to measure the success. And once this is achieved, you can think about the possibilities by yourself. So I'm going to show one or two that are really happening, and we'll leave you with that. So this is a simple example. This is a real project that we're doing now in Germany, and this is a bus depot. Okay, so a bus depot is this place where bus drivers come in at the end of the day, and they're parked. In Germany, by the way, these are all electric. Germany has been a strong supporter of electric public vehicles for the last 30 years. And they come in for recharge, they come in for maintenance. But there's hours and hours in which these bus drivers are sitting there waiting for stuff to happen. They get tired, they get bored, maybe they run over somebody, maybe they fall. It's not a very efficient process. So our task was to do a digital transformation for this premise, for this bus depot. So the outside, it's a physical reality. There's a bus driver. We know where he is using GPS. He's connected to 5G or 4G or whatever, and he can do whatever he needs. But once he moves into the bus depot, we, or this digital entity, takes control. And now it's moving to our system where we're tracking it, we're helping to control it, and we're making it autonomous. And autonomous is, again, a big theme. We all, we've been hearing about autonomous in San Francisco and whatever, but the real revolution is happening in silos. It's happening in controlled environments. And this is where it should start if you think about it. After it's successful in silos, in those depots, in those train stations, then it could probably move to the outside world. Yeah, so this is just a picture of it. You see it's a very quaint, small town in Bavaria. The other one example is probably more relatable to people here in America is airports. Airports are a big mess, and guess what? They're all relying on GPS. If GPS goes away, these airports stop to work. So we're now enabling these airports to have this kind of a backup or GPS resiliency system that they could operate. And of course, by that, also providing them with autonomy, better control, better safety, what have you not. So, shameless plug at the end. The vision, as we said, starts at silos. But what if later on we could physically simulate cities or our world? Think about the possibilities there in terms of energy savings, in terms of welfare, health, security. Not Big Brother's security, but security and safety. And all of these features, if we really could simulate the world, and guess what? I'm sure NVIDIA would be very happy because they would sell much more processors if we need all this oomph power to simulate the world. And we at ASOCS decided that yes, industry is great, bus depots are great, and we're going to continue on doing that. But we also want to now separate this generative physical AI piece to the outside world so we could share it with bigger players, with our competitors, and make it into a technology that can really make an impact on this new world. And so we're spinning out ASOCS, and we're going to keep George and some of the investors, but we're also going to be starting from seed up. This is why I pointed Jerry to you. If somebody would like to join this journey, I can assure you one thing. I have 4 kids, and I learn fast. Thank you very much.